students, welcome to mathgotserved.com. In this clip we're going to be learning how to find the end behavior of polynomial functions. We're going to get started by taking a look at something called the leading coefficient test. Okay, the leading coefficient test is something we can use to describe the end behavior of a function. Now in the chart provided here, we can take a look at what the leading coefficient test is. If you would like to get access to a copy of this document, you can visit our website at mathgotserved.com under Algebra 2, under the topic polynomial functions, and you will find this document to download. Okay, so let's see what the leading coefficient test tells us. There are two things that we're looking at when we identify the leading term. We're looking at the sign of the leading coefficient. Is the leading coefficient positive or negative? And then we're also looking at the degree of the polynomial. Okay, and we're going to ask ourselves, is the degree even or is the degree odd? So based on the sign of the leading coefficient and the symmetry of the degree, we can determine what the end behavior is. So let's take a look at what the chart tells us. It tells us that if the degree is even and the leading coefficient is positive, then the polynomial function is going to rise to the left and rise to the right. If the degree is even and the leading coefficient is negative, the opposite happens. The polynomial falls to the left and falls to the right. When you're dealing with the leading coefficient test, think about even as the same. Okay? And then think about odd as different. What do I mean by that? Well, if you look at the end behavior of both positive and negative coefficient of an even degree polynomial, you find out that either they rise together or they fall together. That's the behavior of polynomials with even degrees. Now let's take a look at polynomials with odd degrees. If the degree is odd and the leading coefficient is positive, the polynomial is going to fall to the left and rise to the right. If the degree is odd and the leading coefficient is negative, the reverse happens. It rises to the left and falls to the right. If you compare the end behavior of the even degree polynomials and odd degree polynomials, you will see that the odd degree polynomials go in different directions, to the left and to the right, whereas the even degree polynomials go in the same direction, to the left and right. Think about the even degree polynomial as happy or sad based on the sign. Alrighty, so happy is for positive leading coefficients and sad is for negative leading coefficients. So that's just something to keep in mind. Before we take a look at some examples, we're going to review how to write the end behavior of functions. Okay, so the notation is very important. Now let's take a look at the four cases. Now let's assume that you have a situation where the polynomial is rising to the right. Okay, so this is right here, and this is, so right is in the direction of the x-axis. Let's write that again. And so right in the direction of the x-axis, and then rise is when you head upwards. Alright, if you go up forever, you're heading towards infinity. If you go to the right forever, you're heading towards infinity. If a polynomial function is rising to the right, we can write it as rises to the right. How do you express this using mathematical notation? So this is f of x and this is x. If a polynomial rises to the right, it simply means that the function, or y, is approaching, this arrow means approaching, approaches infinity as x approaches x. I'm sorry, x approaches infinity. So, rising to the right basically means that f of x, the function, is rising, going up to infinity as you head towards the right direction, positive infinity, in the horizontal orientation. Okay, so in mathematical notation, rising to the right is written as f of x approaches infinity as x approaches infinity. Now let's take a look at the other scenario. What if you were falling to the right? So we have positive infinity on the right end for x, and we have negative infinity for the function y is equal to f of x. This means falls, okay? So in this case right here, so this is case 1. In case 2, what you have is that the polynomial falls to the right. Okay? So if the polynomial falls to the right, how do you write that using mathematical notation? Fall basically means that the function is approaching negative infinity. That's what you have way at the bottom over here. The function approaches negative infinity as x goes to the right, which is infinity. Alright, so if you have an end behavior of this orientation to the right, this is how you write it. F of x approaches negative infinity as x approaches infinity. Alright, let's take a look at case number 3. What if you were in quadrant 3? Let's say you're falling to the left. Okay? So remember, on the y-axis, negative infinity, you're falling. Y equals f of x. And then on the left side, for the x-axis, at the left end, you have negative infinity. This is to the left. Okay, so a polynomial with this kind of end behavior can be described as falling. It falls to the left. Okay, so if a polynomial falls to the left, how do you write this using mathematical notation? You say f of x approaches negative infinity, which means you're falling down as x approaches negative infinity, which means you're going to the left. Okay, now let's take a look at the last case. Let's say you are in quadrant number 2 and the function is rising to the left. Okay, so this is negative infinity for the x at the left end, and then when you're heading up, this is infinity and you're rising, and this is y equals f of x. So how would you write this down? In word form, you say the polynomial, the end behavior, involves the polynomial rising to the left. So the polynomial rises to the left. Okay? Now in mathematical notation, how would you express this? Rising means that the function f of x, remember your vertical orientation, rise or fall, is y or f of x. What is it doing? Is rising, right? So what's at the top? Infinity. The function approaches infinity as x goes to the left. At the left end, you have negative infinity. So this is how you write a polynomial function rising to the left in symbolic notation. Now let's take a look at some examples. The instructions are for us to describe the end behavior of each function. Okay? Example number 1. Let's say you have the function f of x equals negative 2x squared plus x to the third minus 1. Okay, so first things first, we need to identify the leading term. The leading term tells us the degree and the leading coefficient. So what is the leading term here? The leading term is the term with the highest exponent. So we have 1, 2, 3 terms. Which one has the highest exponent? You look at the degree, right? This one has a degree of 2, this has a degree of 3, and this has a degree of 0. We can clearly see that this is the leading term. So let's go ahead and write that down. The leading term is x to the third. Now we can determine what the leading coefficient is. The leading coefficient is the coefficient of the variable of the leading term. In this case it is 1. So leading coefficient is 1. The degree, let's consider that. The degree is the exponent, the exponential value of the leading term. The degree in this case is 3. Okay, there goes the degree right there. Now what do I care about when I am taking a look at the leading coefficient? All I care about is the sign. Is it positive or negative? We can clearly see here that the sign is positive because we have 1. The leading coefficient is positive. If you take a look at the degree, what do I care about here? Is it odd or even? Okay, the degree here is odd. How do we know that it's odd? Because it is an integer that is not divisible by 2. Okay? All even numbers are integers that are divisible by 2. Okay, but in this case you can't divide 3 by 2 evenly. So now we have a positive leading coefficient and a degree of 3. Do you see what your end behavior is going to look like? Well, let's sketch it. So remember that when you have an odd degree, think about different. Okay, it's going to be doing different things at the left and right end. So if it's positive, that basically tells you it's going to be rising to the right and falling to the left. Okay, so let's write that down in word form first, then we will write it in the appropriate mathematical form. So this polynomial rises. Oh, let's do it this way. Let's do the left end first. It falls to the left and it rises to the right. Okay? So that's basically what the end behavior is in word form. Now let's write it using mathematical notation. Okay? So if it falls to the left, that means that the function is going down, falling. It is approaching negative infinity as x goes to the left. What's on the left end horizontally? Negative infinity. Alright, so this basically means the function falls, goes down to the left. It rises to the right. The function is rising, which means it's going up to where? Infinity. Up, up, and away. Okay, as it tends to the right, was at the right end when you're going horizontally? Infinity. So there goes your answer for the end behavior of the function using the appropriate mathematical notation. Okay, let's take a look at question number 2. Let's say we have the function f of x equals negative x squared, or negative x squared plus 6x minus 4. The question now is, what is the end behavior of this polynomial function? So we need to find out what the leading term is. The leading term is the term with the highest degree, and as we can clearly see, the leading term is negative x squared because it has the highest degree out of all three. So this helps us to determine the leading coefficient. The leading coefficient is -1. What is the degree? The degree is the power or the exponential value of the leading term, and in this case it is 2. What I care about for the leading coefficient is the sign, and as we can clearly see, it's negative. And what I care about concerning the degree is the symmetry. Is it odd or even? And as we can see, the degree is even because it is divisible by 2. Now let's take a look at what the end behavior is. So let's make a sketch. Since the degree is even, what does that tell us? It tells us that we're going to be going in the same direction. We're either going to be falling or rising. So what helps us determine if we are rising or falling in the left and right ends? You look at the sign of the leading coefficient. Since it's negative, guess what? We are going to be falling to the left and falling to the right. So let's write down the end behavior in verbal form. The polynomial function falls to the left and also falls to the right. Okay, now let's write this down using the appropriate mathematical notation. Okay, so rise and fall, we're looking at the function. Left or right, we're looking at x. Okay, so let's do it. Fall to the left. So when you fall, what's the function doing? It's heading down to negative infinity. So the function approaches negative infinity as x goes to the left. So as x approaches negative infinity, that's what's at the left end. The polynomial falls to the right. That means f of x approaches negative infinity because you're falling again as x approaches the right end, which is positive infinity. So there goes your end behavior using the correct mathematical notation. All right, let's try another example, question 3. We have f of x equals 16x plus 29 plus 2x to the 4th power. Okay, so what I'd like you to do is pause this video and try out this example, and then come back and hit play to see if your answer is correct. Okay, so now let's go ahead and find out what the leading term is first. The leading term in this problem is the term with the highest degree, which is 2x to the 4th. Okay, so what is the leading coefficient? The leading coefficient is the coefficient of the variable with the highest degree, basically the constant term here. What you're multiplying the variable by in the leading term, which is 2. And then your degree is the exponential value of the term with the highest degree, which is 4 here. Now, what is the sign of the leading coefficient? It is positive. How about the degree? The degree is even. Okay, so these two pieces of information can tell us what the end behavior is. Since it's even, we expect the polynomial to go in the same direction to the left and right. It's either going to rise together or fall together. Since the leading coefficient is positive, guess what's going to happen? The polynomial is going to rise to the left, and to the right. Okay, so let's write down the end behavior in verbal form. We're going to rise, or the polynomial rises to the left, and it rises to the right. Okay, so using the appropriate mathematical notation, f of x rises to the left, which means it goes to infinity as x goes to the left, negative infinity. And f of x rises again, goes up to infinity as x tends to the right, which is going to infinity. So that's the end behavior, right and left end behavior of this polynomial function here. Okay, let's take a look at the last example, question number 4. Let's say the function that we're dealing with here is negative x to the 5th plus 4x to the 3rd plus 3x squared. So what is the end behavior of this polynomial function? So what we'll do first is find the leading term. Okay, the leading term is the term with the highest degree. As you can see here, the leading term is negative x to the 5th. That helps us determine the leading coefficient and the degree. Okay, so the leading coefficient here, this is a 1, is negative 1. And the degree is the exponent value of the leading term, which is 5. The leading coefficient, we want to look at the sign, is negative. Okay, and the degree is odd. So these two pieces of information can tell us what the end behavior is going to be. So let's take a look at a visual before we start writing the verbal and symbolic representations of the end behavior. Since the degree is odd, that tells us something. It tells us that the right and left end behavior will be going in different directions. Okay? So it's either down left up right or up left down right. Since it's negative, you're going to rise to the left and fall to the right. Okay? So let's write this end behavior in verbal notation first, in word form. So it rises to the left and it falls to the right. Okay? Now, using the appropriate mathematical notation, what is the answer going to be? The function f of x or y rises to the left, which means it goes to infinity, rising vertically as x tends to the left, negative infinity. And the function falls, goes down, down, down to negative infinity as x tends in the right direction, which is infinity. So that's the correct mathematical notation for the end behavior description of this function provided here in number 4. Thank you so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your study of polynomial functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below and we'll be more than glad to respond and support you. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.